Have you ever thought about how a contract could just execute itself, with no lawyers, no middlemen, none of that? Well, that's the whole magic of smart contracts on the blockchain. And today, we're going to pull back the curtain and see exactly how they're built using this really powerful language called Solidity. So what is Solidity, really? The simplest way to think about it is that it's the native language of Ethereum. It was literally built from the ground up to do one thing: write the rules for these automated digital agreements. If you want to build anything in this new digital world, Solidity is the tool you've got to learn. You've probably heard the analogy that smart contracts are like digital vending machines, right? You put a coin in, and you're guaranteed to get a specific thing out. It's a great way to start thinking about it, but it kind of leaves you with a big question. Okay, but how do you build the machine? So for this explainer, let's try a different analogy. Forget vending machines, we're going to build a digital house. Every solid house, every single one, starts with a great blueprint. Well, in our world, the smart contract code is that blueprint. It's the master plan for a structure that's built on pure digital trust. It lays out every single rule, every room, every tiny feature before a single digital brick ever gets laid. And just like a real blueprint has all that official info in the corner, a Solidity file has a very specific structure you have to follow. You kick things off by declaring a license, which is super important for open source stuff. Then you tell it which version of Solidity you're using. You can think of this as making sure your architect and your construction crew are looking at the same building code, so there's no confusion. And then you get to the heart of it, the contract itself, which is the main outline of our house, holding all the key parts like our variables and functions. All right, now for a really, really important concept. In the real world, building materials obviously cost money. Well, on the blockchain, creating something permanent also has a cost. And when I say permanent, I mean it. Once you build it on the blockchain, it is there for good. That permanence, that immutability, is what creates all the trust. But yeah, it definitely comes at a price. And that price is called gas. See, every single little thing you do on the Ethereum network, every calculation, every bit of data you want to save, it all requires a small fee. Just think of gas as paying for your digital construction crew and all the materials they need to lay the foundation of your house on the blockchain. And this is why choosing your building materials wisely is absolutely critical to managing that cost. Solidity gives you three main spots to put your data. First, you've got storage. This is like the concrete foundation of your house. It's written permanently to the blockchain, and it is very expensive. Then there's memory. This is like temporary scaffolding. It only exists while a specific task is happening, and then it's torn down. And finally, there's Cal data, which is like having the blueprints right there on site. It's data that comes from outside that you can read, but you can't change it. This table really nails it. It shows you the right tool for the job. If you have data that needs to last forever, you have to use storage. That's your foundation. For quick, temporary calculations inside a function, you use memory. That's your scaffolding. And for inputs that you just need to look at, Cal data is your best, most efficient choice, like checking the blueprint. And just to give you a sense of how big the cost difference is, writing a brand new piece of data into storage costs something like 20,000 gas. That is by far the most expensive thing you can do. It's literally like pouring a whole new slab of concrete for your foundation. You only do it when you absolutely have to. Okay, so we've planned our foundation. Now it's time for the fun part, actually building the rooms and features of our house. In Solidity, the building blocks for all of this are what we call data types, basically the different kinds of information our contract is going to work with. Let's break these down real quick. Integers are just your numbers. They're the bricks and beams of your whole structure. Strings are text, kind of like the glass in your window panes. Booleans are super simple. They're just true or false values. Think of a light switch. It's either on or it's off. An address is a unique Ethereum account, basically the mailbox for your digital house. And structs are cool because they let you create your own custom things, like building a unique piece of furniture out of wood, metal, and fabric. Now, some parts of a house should never, ever change once they're put in place, right? Like a main steel support beam. Well, Solidity has the exact same concept for its variables, and it is incredibly important, not just for security, but also for saving on those gas costs we keep talking about. So this table shows the two main ways you can create these unchangeable variables. A constant is like a part that's made in a factory. Its value is locked in before you even start building. An immutable variable, on the other hand, is like a custom-fitted part. Its value is set just one time, right when the house is being built. So what's the key takeaway here? Both are incredibly cheap to read from because they don't use that super expensive storage space. So we've built our house. That's great. But now we need walls, doors, and some good locks to control who can get in and what they can do. In Solidity, we handle this with something called visibility modifiers, and let me tell you, they are absolutely essential for keeping your contracts secure. A public variable or function is basically the front door. Anyone, whether they're inside or outside the contract, can access it. Internal is more like a staircase that only connects floors inside the house. It can be used within this contract and any other contracts that are extensions of it, like a new wing you build later. And private, well, that's a locked safe in the master bedroom. It can only be accessed from inside the one specific contract where it was created, no exceptions. So, what are the golden rules for a solid build? First, and I can't say this enough, write to storage as little as possible to save on gas. Second, always prefer using temporary, local variables for your calculations. Third, use special functions called view and pure for just reading data. They're free to call from the outside. And of course, use clear, descriptive names for everything and be really careful with global variables because some of them can actually be influenced by minors. All right, we've got our blueprint, we've picked out our materials, and we have our security plan all laid out. The very last step is the actual construction, taking our code and putting it on the blockchain so people can actually start using it. And this all happens through a process called compilation. You can think of the Solidity compiler as a master translator. It takes your human-readable blueprints and turns it into two critical pieces. First is the bytecode. That's the low-level machine code that the Ethereum network can actually understand. And second is the ABI, which is basically a user manual that tells other apps and contracts how to talk to your new house. Now, once our house is built and on the blockchain, there are two ways to interact with it. A call is like touring a model home. It's a read-only visit. You can look at everything, check out the state of all the rooms, but you can't change a single thing. And because you can't change anything, it's totally free. A transaction, though, is like hiring a contractor to do a permanent renovation. It actually changes the state of the house, it gets recorded forever on the blockchain, and it definitely costs gas. So how do developers put all this together? Well, they use tools that create a sort of digital construction site. One of the most popular is the Remix IDE, which is basically an online workshop where you can write and test your code. It even comes with a practice blockchain that just runs in your browser, so you can test things safely and for free. Then, a tool like MetaMask acts as the final bridge, connecting your browser to the real Ethereum network when you're ready to build for real. So as you can see, a smart contract is so much more than just a few lines of code. It really is a digital structure designed and built with care and intention. Every single material you choose, every security feature you add, every line in that blueprint has a real cost and a permanent consequence on the blockchain. So the only question left is, what will you build?